Welcome to part two of the SPC Tornado Damage Intensity training. Again, my name is Kevin Scow with the Central Region Convective Warning Improvement Project. And this presentation will focus on case examples utilizing the tool in a variety of different scenarios. Now, before we get into those scenarios, there are two different ways to use the tool that I wanted to touch on. The first and most likely way you're going to be looking at this tool is by trying to estimate the peak intensity of the tornado along its entire path. And this is obtained using that rotational velocity duration selector that we have in the tool. And this is best used during the intensification and mature phase of a circulation. Now, if you're trying to use the tool for, say, an instantaneous intensity estimate, it's recommended not to use that duration selector in the tool and leave it at the default of 1 to 5 minutes / 1 to 3 scans. And this is primarily best used during the weakening phase of a circulation and may underestimate the tornado intensity elsewhere in its life cycle. And as we go through the case examples, we'll show how each intensity estimation technique would work. The first example we'll go through is from southern Wisconsin on February 8th, 2024, the first February tornado recorded in Wisconsin. This was a longer tracked EF2 tornado with a good sampling of damage indicators along its path. The significant tornado parameter with this event, there are three different panes here. The effective STP is on the top, the fixed layer STP is on the bottom, and the left panes are at -1 hour from tornado. The middle panes are during tornado, and the right panes are an hour after the tornado. And as you can see, during the tornado, we had an STP of 1 for both the effective and fixed layer. So for the sake of argument, let's just say we had a spotter watching this event and said we had a tornado ongoing right here at 2339Z. And you may look at this and see, well, there is a broad circulation there. We should use that. But is that really the circulation for the tornado itself? Here is the 40 dBz contour of reflectivity from the left pane overlaid on velocity on the right-hand pane, the storm relative velocity. And you can see what you might consider that couplet region is a bit broad and a bit ahead of the higher reflectivity. So we might actually be sampling inflow into the storm in this region, whereas the area of broader outbounds could be the left flank velocity enhancement. And looking more closely, the likely tornado circulation in the appendage hook echo of the storm is a little bit displaced to the west. You can see a very small couplet there, very hard to discern. But as we go through the event, you'll see why this was probably more likely a tornado. And sampling the rotational velocity of this couplet is a little bit difficult because it's so weak, but generally it's around 15 knots, and you can see the arrows denote the pixels I used for calculating that VROT. And once we apply all of our inputs here, less than 25 knots, it's the first scan. STP is between 1 and 2. It generates a wind speed range of 70 to 110 miles per hour. Now, as we go through the rest of these examples, we'll use a table on the right-hand side of the image to list all the important values that are going into the tool and its outputs. So here in this example, the time is listed here, 2339Z. The VROT value is listed next. And you'll notice there's two numbers in parentheses next to it that are rather important. The first will be the total number of minutes on the left-hand side and the total number of scans on the right-hand side, where that VROT value is within or greater than the bin selected in the first step of the tool, as shown in this example here on the bottom. And the time is determined by the number of minutes that has elapsed between the current scan and the previous scan. So that VROT value is valid. In this case, the previous scan was at 2337Z. That VROT value is effective for 2 minutes between that previous scan and the current scan. The STP will be listed then further to the right. That usually doesn't change throughout the course of the event. And then we'll have the two different intensity estimation methods listed here. First will be the peak intensity. The next will be the instantaneous intensity. And finally, they'll have the results of the survey here. And these last three boxes will be color-coded by EF scale listed here on the bottom. So the blues will be EF0 all the way up to the pinks at EF5. So now moving forward in this case, we moved up 2 minutes to 2341Z. You'll see that RFD appendage has gotten a little better defined. If we go to the velocity image, the VROT hasn't changed. It's still 15 knots. At this point, the tornado was very ill-defined at the surface through the storm survey, and there may have actually been a break in the tornado path at this point. It's tough to say because the path kind of jogged in the survey. The duration has increased by 2 minutes, so we went from 2339 to 2341. So the total duration of that 15-knot VROT is now at 4 minutes. It's the second scan with this in it, and the numbers haven't changed so far. The survey results were 90 miles per hour at this point. Now moving forward, that RFD appendage continues to get better defined, and you'll notice that the velocity couplet has gotten a lot better defined, a lot more structure to it. You'll notice the left flank velocity enhancement region has started to kind of couple in with it, and you can even still see that inflow region in the storm, but it isn't as defined, and that old couplet we were looking at previously has now taken over. So we've now jumped a bin to 25 to 39 knots with our sampled VROT value of 35 knots. And so this counter is going to get reset. It was 3 minutes has elapsed between 2341 and 2344Z. So that becomes the default number here for the VROT of 3 minutes, and it's the first scan. You'll notice our numbers for both the peak and instantaneous velocity have gone up. The survey results are still showing high EF0, maybe a low EF1 in the area. Looking ahead to the next scan at 2346, so we've advanced 2 minutes. We still have 5 minutes of 30 knots or greater VROT values, and so the peak and instantaneous velocities remain the same. Moving forward, at 2349, the VROT values jump to 53 knots, peak intensity and instantaneous intensity both of 95 to 130 miles per hour, which corresponded very well with some of the strongest damage seen in the damage survey, estimated at 130 miles per hour. Again, it's only been 3 minutes, so the counter gets reset again, 3 minutes and 1 scan for this 50 knots or greater VROT value. The next scan, the VROT values actually drop back into that 40 to 49 knot range bin. And you'll notice we count that 53 knots as part of our counter here for the 40 to 49 knot range bin. So we have 6 minutes of values of 40 knots or greater. And this actually causes our peak intensity to go up slightly to 135 miles per hour, even though our instantaneous value has dropped slightly to 85 to 120. And this is again because that rotational velocity duration selector moved up from 1 to 5 minutes to 6 to 15 minutes, and that caused our upper bound wind speed range to go up slightly to 135 miles per hour. Moving ahead, not much changes here over the next few scans. 2354, still in that 40 to 49 knot bin for VROT. Again, same thing here at 2357, not much changes in the peak and instantaneous velocity, rotational velocity, and even the same with the survey was sitting at a solid EF1. Again, at 0Z, not a whole lot changes. And now we go to 0003Z. We fall down to 37 knots, so we actually fall a bin, one of the VROT bins. But because we've had such a long duration of VROT values of 30 knots or greater, we have to recalculate the duration, which is well above that 15-minute threshold for the last slider. So we actually advance that VROT duration slider up to that 15 minutes or greater level, and that causes our lower bound estimate of the peak wind speed to jump up to 110 miles per hour. So this is what it would look like. We would enter 25 to 39 knots, 15 minutes or greater, and you'll see it concentrates that expected bin in that 110 to 125 range. So that 110 in the lower bound brought up our estimate. And for the rest of the track, moving forward at 60006Z, VROT continues to fall. Our peak intensity hasn't changed. Instantaneous is still tracking well with what we saw with the survey. And it continues on at 0010Z. VROT values still hovering in that 25 to 39 knot bin. And they continue to fall even further as the tornado dissipates. And you'll see the instantaneous values are obviously tracking along much better with the survey versus what the peak would have given us. So the peak kind of plateaued out, obviously, because VROT wasn't increasing anymore, and we'd already maxed out our duration. So the instantaneous tracked better with the survey at the end of the path. So this case demonstrates differentiating a tornadic circulation from surrounding wind fields, which is so important when it comes to ascertaining the correct VROT. So early in this case, it could have been possible to mix up the inflow into the storm with the actual circulation of the tornado. And again, accurately calculating those VROT values from within the tornado circulation, sampling the pixels to find the correct ones and weeding out any spurious pixels we may have had. It also demonstrates the tool behavior for both instantaneous and duration-based intensity techniques, and showing the strengths of both of those methodologies, especially the instantaneous part when the tornado is on a weakening trend. The second case we have is the Rolling Fork, Mississippi case from 2023, and this was a more unique tornado in that much of the damage in this longer track tornado, much of the worst damage occurred early on in the tornado path. And this is where we had the EF3, EF4 damage. Again, here's the effective and fixed STP, both an hour prior, during, and an hour after the tornado, values in the 5 to 6 range at the star of the location of the tornado. So again, this had a mesocyclone going on well before the tornado occurred, but we need to start using the tool after a tornado is reported and we know a tornado is in progress. So in this case, the tornado starts just around 0056Z, and so that'll be our first data point for the tool. VROT of 57 knots sampled across the circulation. That puts a peak and instantaneous wind speed estimate of 110 to 145 miles per hour, and the survey only showed winds of a little less than 100 miles per hour at this point. Moving forward at 0058, VROT actually goes up to 60 knots. So again, we are moving up in the rotational velocity selector. The duration gets reset technically, and the winds correspondingly go up to that 115 to 155 range for both. But the survey only shows 94 miles per hour. And even the same at 1Z, we're at 65 knots. And the peak and instantaneous velocity estimates are still way lower than the survey. And this is primarily a function of the tornado occurring over rural areas, one of those overestimates we're possibly going to see for tornadoes. Now, the tornado afterwards starts moving into more of a populated area. So 2 minutes later, the VROT values have increased greater than 70 knots. So again, that duration slider gets reset once again. The peak and instantaneous velocity measurements are 120 to 165 miles per hour, and the survey is starting to reveal EF2 damage. 2 minutes later, VROT of 76 knots, duration of 4 minutes and 2 scans, and the peak and instantaneous haven't changed yet because we haven't been able to move that duration slider at all, but the survey is revealing low-end EF4 damage. We drop just a little bit to 69 knots here at 107Z. The peak doesn't really change much because we achieved that with the 70 knot VROT earlier, but the instantaneous starts to fall a little bit. And finally, at 109Z, we have another 2 minutes of VROT values greater than 70 knots. So we've now been able to have 6 total minutes of VROTs in excess of 70 knots, which allows us to move up in that duration slider and achieve low-end EF4 estimated peak wind speeds in the tornado, even though the instantaneous still says 2 to 3. So again, showing that duration part of the tool will help get your wind speeds up closer to reality during that mature and strengthening stage of the tornado. The VROT values go up even farther. Again, we're in excess of 70 knots for a VROT, so not much can change even though we're at 86 knots. The duration hasn't changed, although you notice the EF rating has back down to EF3 as we're starting to move into more of a rural area again. Same at 113Z, VROT values in excess of 70 knots. We're at 10 minutes of those values, and we only have EF2 ratings at this point on the damage survey simply because we moved off from a lot of damage indicators back into a rural area. So this case demonstrates utilizing the tool for a higher impact tornado situation and calculating VROT values for stronger and larger tornado circulations. This highlighted that potential high bias you may see for stronger mesocyclones as a new tornado develops or for rural tornadoes. and also showcases, well, it wasn't explicitly shown, but when your STP values are 6 or less, the tool has a slower ramp up to those higher EF4 and EF5 probabilities. The last case we're going to show is the Greenfield, Iowa tornado of May 21st, 2024. In this case, the effective and fixed layer STPs are right around 4 to 5. And again, you can see that gradient in the STP where, especially in the fixed and effective during the event, the higher STP values were off to the east. Again, a function of that lower grid spacing of the RAP model used for the archive mesoanalysis data. And I want to skip right to the end of this case and forego the steps showing the calculations like we did in the other two cases, because I want to highlight an important caveat of the tool, and that being that the limitations of the radar data will be reflected in this tool. In this case, the tornado was moving through Greenfield at this point and was producing damage up to mid-range EF4 with wind speeds estimated at 185 miles per hour. But because the mesocyclone was contracting, the radar was not really able to sample the true strength of the circulation. In fact, all we have is a gate-to-gate couplet here with a VROT value of 49 knots, and this would give us an instantaneous velocity measurement, estimated intensity of 90 to 130 miles per hour, so well lower than the true strength of the tornado at this point. And even the peak intensity estimation was falling short of that EF4 rating simply because the circulation was not quite able to reach those higher VROT values throughout much of its life. So this case demonstrates the shortcomings in the radar data that will likely be reflected in the tool. In this case, the mesocyclone circulation was too narrow to be properly sampled, and thus the estimated tornado intensity came out too low. So that wraps up part 2 of this training session, and hopefully you're able to use this in operations.